This is chapter 10, problem 18, which is we can roughly model a gymnastics tumbler as a uniform solid cylinder of mass 75 kilograms and a diameter of 1 meter. If this tumbler rolls forward at 0.5 revolutions a second, A, how much total kinetic energy does he have, and B, what percent of his total kinetic energy is rotational? So in order to find the rotational kinetic energy, we use the equation 1/2 times inertia times angular velocity squared. And so we have, so we can plug in for our inertia that m mass times radius squared divided by 2 is equal to our inertia. So we plug that in for our inertia, and then we're able to simplify it down a little bit by cutting out, or by adding the half to the 1/2, and so we get 1/4, and then we plug in the numbers for mass, which is 75, the radius is 0.5, and the angular acceleration, or angular velocity, is 3.14. And I forgot that we kind of figured that out earlier. Anywho, that's just when we can convert it over to that, so to radians per second. So we get the, when we plug those numbers in, we have 46.26 joules. Then, as far as translational energy, kinetic energy goes, our translational kinetic energy is equal to 1/2 mass velocity squared. We have our velocity is equal to radius times angular velocity. So we plug that in for velocity, and we're again able to simplify down a little bit, take out the parentheses essentially, and square the r and square the angular velocity. Then we plug in our numbers again, and we end up with 92.43 joules of translational kinetic energy. So then for part B, all we have to do is divide the we get the total kinetic energy is 138.7 joules, as shown here, with the rotational energy and translational energy. And then we take the rotational kinetic energy and divide that by the total, which gives us that the rotational kinetic energy is 33.34% of the energy.